Okay, let's continue. Right? Okay, so this question is about force again, right? The path
Is
of.
this whole worksheet about forces?
Wait, are we on the same page?
No.
How come mine is a helicopter?
Oh yeah, it's fine.
You're done the helicopter, is it? Can you tell me what's your answer? Why did he carry out 3 times?
To reduce human errors. Why did every time I do 3 times?
To find
not correct.
out
To
if
ensure
the
the fair test.
stronger the
Isn't it the
pull
same?
is, the further
Okay.
it will.
No, the trick is wrong. Why did he do it 3 times?
Reduce
To
human
see
errors and
Reduce
to
human
ensure
errors
a
so
fair
as to
test.
ensure a
Fair
fair
test.
test. Okay, so to
This is the
reduce
easiest answer.
human error.
And even this tuition center is I find myself one. Okay.
Huh? What?
This tuition, right? I
To
find myself.
reduce human error so as to.
This tuition she fed herself.
I found it on myself, but I knew that I needed help from myself.
How do you find us?
I just walked around. I just walked around Serangoon Gardens and then I was at my age. I was eating my own lunch. I was such an emo kid. So I just saw, one day I saw a lot of people come up, remember what is this, and I just took the
The
newsletter.
emo kids not me, right?
Okay, Dimitri.
I saw the newsletter, I'm like, oh, it's pretty good. I'm like, oh, the teacher seems
Yeah.
quite nice. So
Yeah.
I just came here and I'm still here.
Even you came out and inquired yourself. Wow, very good. See, independent. Good.
So shy.
Okay, let's continue. Right? Give a possible reason why the distance traveled by
Different forces is being differently applied on different tries.
Why?
They are just talking crap.
The distance traveled by each.
No. Different forces is being applied on different tries. That's why it's
Okay,
Right.
so what did he do? He had to launch this thing, right? So when he launches, he has to pull the what? Pull the.
pull. They never say
Elastic.
anything about pulling.
I mean,
It's a toy helicopter.
yeah, using a setup, he has to launch. He pulls this thing, right? The rubber band behind. So what's the reason why the distance is different, even though the mass was the same? So we say that one possible reason is that he pulled the launcher to different lengths before releasing.
So
okay?
it's not different forces.
No, because you pull different length, this resulted in what? Different amount of force.
Also, I never say complete.
Correct. The idea is correct, right? So, you say that it is possible that what's the guy's name?
Daniel.
That Daniel stretch the launcher or the rubber band in the launcher.
Oh, wait, I remember how I got to know Ace Chorus because I was eating and then a newsletter. Then I remember that what's my adopted sister Michaela, right? Yeah, it's Michaela.
Oh, Michaela.
Yeah, then she happened to be online. I asked her like, hey, you B6 what tuition you are? Then she's like, oh, Ace Chorus. Oh, I'm there. And she like, okay lah, you go lah, huh? I'll be a cheap no. She like, okay lah. I'll be like, okay lor. Then yeah lor.
Thanks. Okay.
This is how you
Okay,
do it.
wait. So that Daniel stretched rubber band to to different lengths before launching. Okay, this results in different elastic spring force.
I have to go to school on Monday. It's a waste of time.
Okay, different elastic spring force for each.
I need to go and get pen from receptionist. I don't have pen ink.
Go. Hurry up. I got a pen here, eh? Go.
Okay, thank you.
Okay, so this results in different elastic spring force for each try. And hence, I'm finished,
Oh no.
because they asked about what? The distance, so you must end with the distance traveled was different. The distance traveled was different. Okay, so remember I always say that when you're answering this question, don't be stingy. Don't say that I have 1 mark. must only write one word. No such thing, right?
Will there be snack?
No,
Break?
no time already. Let's continue. Okay, next question.
Wait, wait. How many pages did we do? 1, 2.
Okay, so we have an experiment over here. What property was
4.5.
being tested?
How strong the material?
Yeah, very good. Okay, the strength,
Joe, which part are you now?
the strength of the material.
Joe, which page are you now?
There. That one.
What?
I don't have the
No,
table.
oh.
The strength of the material was being tested. Okay, so one of the variable has made this an unfair test. Which made this test unfair?
The thickness of the
Yeah, very
material.
good. Okay, the thickness. Why?
They never ask what. So
Yeah, no, but you need to understand, right? The thickness.
So it's like different thickness, then it will be like different forces for
Yeah.
it to break the material.
So you have to specify, the thickness of material should be what?
The same.
Should be the same. Okay, that's the thing here. So Luther wanted to test the relationship between the variable in B
Make the thickness the same
and the amount of force. What changes should Luther make?
Make the thickness.
No. Now he wants to test the relationship between the thickness and the amount of force. You want to test the thickness and the amount of force.
Make the force the same.
That means if I put different thickness, right?
Make the materials the same.
Yes, okay, he should use the same material. So Luther should use the same material but with different what?
So Luther or Luther?
Thickness.
The person's name is Luther or Luther?
Luther. Okay, so she use the same material but with different thickness. Right? Very straightforward, okay?
送分的。
All these are one mark questions, not so much to discuss about.
How do you get your fingers?
Okay, next we have an experiment. Jae-woo, right, plays a
Oh, it's a
block.
Korean name.
Yeah,
Yeah, I know how to write it.
Okay. Okay, let's look at this, right? Give a reason why the block slid downwards after Jae-woo released it.
Because J is J.
Wait,
This is
what
a
is the
block.
thing? Is it steam or what?
No, it's a hand.
Oh, looks so weird.
Because the block overcame the frictional force of the slope. The friction of the block and the slope was overcame.
The
Was overcome.
friction of the block. Okay, wait. Right, so the question is why give a reason why the block slid downwards.
Because
So after Jae-woo released.
the slope and the
So we start with after Jae-woo released. Understand? So after Jae-woo released, I'm writing it here.
I want to vomit. No, the cheese is making me really sick.
what did you eat?
Release.
Then I ate too many chips. Then I didn't go and vomit.
Serious. Okay, after Jae-woo released the block, what happened? Continue.
Sorry, do you
After you release the block, what happened?
generate
The weight of the
the block, the
overcame the frictional force between the slope and surface of the block. this cause it to slide down. Okay, understand change? Right, so what was the thing that it had overcome? It had overcome the frictional force between the block and the slope. Right? So the weight is the one that overcome the frictional force.
Are we just going to wait for her?
No, we'll continue. Okay? Done. Then the next question is, so J Wu repeated the activity using similar block of different material. It slid and stopped before point C. J Wu concluded that the two blocks stopped moving because there were no forces. No forces were acting on the block. Give two reasons why he could not make such a conclusion. So are there no forces acting on the block when he stopped at C? No, right? Okay, why?
Because the surface of it is rough,
So
once it starts only a bit, then from there it stops because of the surface.
what did you just say?
Eh,
No, they're asking you why he cannot conclude that there's no forces acting on it, even though it stopped at C.
I'm gonna talk later about myself.
What about that?
I just vomited everything out.
Serious? Do you need some more water?
I think it was indigestion between this and that.
Yeah.
Because
Water.
this is sweet and that is salty.
Do
So
I
yeah.
need plain
Do you
water?
need water?
Oh,
Water with lemon.
Rest.
my hip is spinning.
Rest. Okay. So let's just listen, right? So give two reasons why he
Oh,
cannot.
what's
make
A?
A was here again, This one. Okay, so the weight of the block overcame the frictional force between the slope and the surface. This caused it to slide down. So Dietrich, can you still look at the next question and tell me why?
Give two reasons why he cannot make such a conclusion. I keep on thinking about the two surface. The surface of the block, the surface of the...
Now first you need to understand the question, right? You need to understand what the question is talking about. What's the question talking about? When it stopped at C, the thing stopped at C, and then they say that you cannot say there's no force. Why can't you say there's no force? Even though it stopped at C.
What the gravitational potential energy has been used.
No. It's force. This is about force. No force. Is it true that when the thing stopped at C, there's no force?
No.
Yes.
They already told you you cannot make such a conclusion, right? So why? Because there is what other forces are present?
Sound,
No.
frictional,
Yes, right.
and gravitation.
Yes, very good. So the two are, first reason is there is still frictional force present as it prevents the block,
Is that clinic open on Saturday?
probably
But not that late, right?
from, you probably want to call your parent
No, it's okay.
from sliding down further.
This is why you don't eat that much potato chips.
How much you eat? Half a packet.
Like water.
But,
So you only eat like...
I think it was,
oh, sorry,
I think
frictional
it's this
force.
because just now I accidentally tasted them together. It tasted
By
really bad, but yeah.
By fraction, she'll be left only 1/4.
Right, so we see that there's still frictional force present because it prevents the block from sliding down further. Secondly, there is gravitational force present. Now how can we tell there's gravitational force present? Okay,
Because it hasn't reached like the end yet.
no. This is not gravitational potential energy.
Oh,
I'm
yeah.
saying that there's gravitational force. Now, what happens to the block if there's no gravitational force?
Then we must like
Huh?
eh,
What happens to the block if there is no gravitational force?
it won't.
Oh, the trade is not thinking properly. Where on Earth is there no gravitational force?
Of the
Space.
Yeah, outer space.
Zero gravity.
So what happens to things that has no gravitational force?
Just floating.
Yeah, so if there's no gravitational force, what happens to the block?
You float.
Yeah, you float, right? So there's gravitational force because there's gravitational force present because the block did not float. The block is still
I don't think that I say what I said this year.
is still on the slope and did not float away. So, away, right? So it is wrong for him to say that there are no forces present because there are still two forces present. One is frictional force, and the other one, of course, is the gravitational force that keeps the block stuck to the slope. You look really pale, you know.
Not really.
Yes, and no blood already. Okay, next question. So did the volume of the block affect the amount of force acting on the spring?
Yes.
Yes, right. So explain how you came to your conclusion. So yes.
Because when there's nothing, no block added, the spring was just normal. But when the block is added, the spring lowered down. The spring extended.
Okay. So yes.
I think it's because the block occupies space.
No, they're asking. Explain how you came to your conclusion. So you have to look at the table. Based on the table. Okay, the table over here. What we see is that when we put the mass, we increase the mass from 25 to 75. What happened? Yes. So according to the data, when a mass of 50 gram, when there's an increase in, when there is an increase of mass by 50 grams. Okay, you can see from 25 to 50, right? What happened to the H?
The length of each.
The length H increased by 1 cm. Oh no, our answer is wrong.
Luckily I did not know it.
Okay, they asked about the volume. They did not ask about the mass. Wrong. So the answer is no.
Huh?
Sorry, I didn't see the volume, right? I thought they were asking about the mass. So no. Okay, so when the volume was increased by 20 cm cube, the length of the spring remained the same. Okay, as we can see over here, right? So when they increase the volume by 20 cm cube, the length of the spring remained the same.
I had to choke with the Pokemon.
Okay, so remain the same, even though the volume was increased. Right? Did you understand
Oh,
this?
I remember how my friend got into Pokemon Go. He changed the app store, the phone, her phone, the app store to like another
USA,
country.
possible.
Huh? You can change your.
Okay, no, don't worry, come.
I was gonna change to download the app and then I 倒过去.
Okay, come. So, Xiaoqi repeated the same experiment. The mass of the milk was 25 and the volume was 100. What would be the value of HB? So now you change the volume to 100 and the mass 25. Dietrich, can you answer this?
Okay, to 25 gram, the volume is 100.
What do you think is H?
Wait, this is by maths, right?
No,
Oh shit.
science. So I changed the volume. Remember we said that the volume, does volume affect the spring?
Yeah.
No, volume doesn't affect, only the mass.
0.5, 0.5.
Ah, very good. So H will remain at,
0.5.
yeah. Okay, H will be 0.5. Oh, 0.5 cm. Okay, so at the end of the experiment, the train was
Square.
empty. Cm, just cm.
Oh, okay.
Based on the observation volume of the spring.
Oh, yeah, see, yeah.
So at the end of the experiment, you remove everything from the tray.
The spring can be compressed.
That H was 0 cm.
The spring contains meat.
Hmm? Yeah. The tray. Wait, so what's the property of the spring? The spring is what?
Compressible.
Elastic.
It's not compressible because you can.
It's not compressible. The spring is elastic. Alright? Because you need to understand what is the meaning of elastic. Return to the original length after being stretched. Okay, it can return to the original length after it is being stretched. Okay? Next one.
Oh, what happened?
What can Kai conclude?
Kai the ninja group.
So the bigger the surface, the more force is.
Being applied.
Wait a minute. Let's look at the. Wait, there's something different. Wait first.
One was standing, one is lying. Let's see, and the large one and the smaller one. Oh, the large one when he's standing
The
up.
average is all the same.
Yeah, the average is the same.
Like, no matter how big the
Average are the same, but
is.
the tries are not the same.
Oh, okay, because it's a glass sheet. So what can you conclude?
Glass is glass is not lubricant.
Glass is not, but it has a very smooth one. Surface, right? So you see that the average is the same. It doesn't matter the surface area. So you can conclude that the surface area does not affect the surface area of the block does not affect the amount of force needed to move it across the glass sheet. Okay, because it's a glass sheet, so it's smooth. Right, so the surface area does not affect. Next one.
No. Wait, I see, wait.
So he wants to choose a suitable type of floor tiles repeated the earlier experiment using the same setup, replacing the glass sheet with floor tiles A and B. Right, so in the new experiment, we have floor tile A and floor tile B. Okay, so which are floor tile should he use for the bathroom?
He should use the larger one.
What?
No, sorry. He just check.
Which one should he use?
The smaller one because the average is smaller.
The larger one.
The larger one.
Something larger than the other.
Huh? No, literally you must understand the logic, you know, it's not tikam choose something, right? Why the larger one? Now you look at the force,
Because it takes bigger force means like
more friction.
if more friction, then it will be
Yeah.
harder for it to overcome.
Yes, okay. So Kai should use the larger floor tile. Okay, so you have to explain why. Explain your answer. Because this is about you will not slip and fall. So based on the data, what do we see? From the larger floor tile, the amount of force is larger. Right, so we say the amount of force needed to move the block across the larger floor tile is more than for the smaller one. Okay, this shows that there's what? More friction. And hence
You
useful.
put hands a lot of times.
Really? No, first time only.
No, there's one there. Hands very small.
No, floor tile is
Oh,
more
floor
than for
tile.
the smaller one. This shows that there is more friction, hence useful for the bathroom floor. To prevent slip fall easily. Right? 2 marks, right? A bit more. Right? So you have to say that more force is required because there's more force, so likelihood is that there's more friction. You have to link the two. And then you have to say that because there's more friction, so people will not slip and fall in the toilet so easily. Okay? Right? I think we can stop here.